If you have an equation in this format here, you can write it like this. If you have an equation in this format, you can write it like that. In order to work out r, which is present in both, you can apply this equation and these two pieces can be used to work out the angle. Okay, for now, I just want you to write that down. I'm going to go through two examples which makes use of all of this, and then you're going to try one on your own. So, show that you can express sine x minus root 3 cos x in the form blah blah blah. Okay, step number 1 is to work out your angle. So, here's what we're going to do. We're going to use that second piece of information there. The first step is to make sine x minus root 3 cos x equal to r sine x minus a. And now you're going to apply your addition formula to sine x minus a. Like this. Okay, so from here to here, you've just used the addition formula. Right, now, you're going to make r cos alpha equal to 1, and you're going to make r sine alpha equal to root 3. I know this because I'm equating the sine x's and I'm equating the cos x's. Yeah? So if sine x equals r sine x cos alpha or cos a, that means sine x over sine x equals r cos a. So 1 equals r cos a. That's how I got to it. Okay, now that I have r cos alpha and I have r sine alpha, I can work out tan alpha by doing root 3 over, or shall I say by doing r sine alpha over r cos alpha, which is root 3 over 1. The r's cancel out, you end up with tan alpha equals root 3. Okay? Right, so alpha equals pi over 3 in radians, because the question here says alpha is in radians, and it works. Okay, that second bit said to work out r, you do the square root of a squared plus b squared. A squared is the coefficient of sine x, and b squared is the coefficient of cos x. So to work out r, we're going to do the square root of 1 squared plus root 3 squared, which is the square root of 1 plus 3, root 4, which is just 2. So r equals 2. So if we want it in this form, 2 sine x minus pi over 3. There we go. Final answer. I hope that made sense. Part B says sketch the graph of y equals sine x minus root 3 cos x. What you're actually going to do is sketch this graph. You would do that by timesing all the y values by 2. So the maximum and minimum is now minus 2. Sorry, 2 and minus 2. And then you're going to shift everything to the right by pi over 3. So it should look something like this. 2 minus 2. This is going to be pi over 3. And this is going to be 4 pi over 3. Okay, cool. That's the first example. Let's have a look at this one. Now in this one, you need to put it into our cos form. So we're going to do the same thing as before. 12 cos theta plus 5 sine theta is r cos theta minus alpha. Can you apply the addition formula to r cos theta minus alpha, please? So you should have this. R cos theta cos alpha plus r sine theta sine alpha. Because remember, inside the bracket can be negative, outside the bracket is therefore positive with the cos addition formula. Okay, we're going to equate the cos thetas and we're going to equate the the sine thetas, sorry. So that means 12 equals r cos alpha, 5 equals r sine alpha. Okay, equating coefficients. That's all you're doing, really. We can now put it into tan alpha by doing r sine over r cos, 5 over 12. So tan alpha equals 5 over 12. Alpha, by doing the inverse, is going to be 22.6 degrees. And we're working in degrees now. You could have done it in radians, but I think the default is usually degrees. So unless they've specified, you can just work with degrees. Okay. That's our alpha done. Now we need to work out r by doing the square root of 12 squared plus 5 squared, which is root 144 plus 25, which gives us 13. So your final form is 13 cos theta minus 22.6 degrees. Perfect. Okay. Part B. Find the maximum value of f theta and the smallest possible value of theta at which it occurs. Okay. The maximum value of cos x usually is going to be what? In the graph, what's the maximum value it can take? 1. So, if you were to substitute that into this, let's say everything inside your bracket is, it makes the maximum. So, 13 times 1, 13. That's the maximum value. I can't spell value. There you go. That's the maximum value. Now you need to find the points at which this occurs. And specifically, you want the minimum point, right? The smallest value. So what you're going to do is make cos theta minus 22.6 equal to 1. Okay? So theta minus 22.6 is minus 360, 0, 360, blah, 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 blah. If you just look at the cos graph, that's the case, right? Now, you want theta. You don't want theta minus 22.6. So when you solve, you get 22.6 degrees. You get 360 plus 22.6, 382.6, and so on. Or you can have some sort of negative value here. The minimum value, though, would be this. That's the smallest possible value. Oh, okay, that was a lot. Hope it made sense, though. I want you to try a question completely on your own. I want you to try question 9, please. Okay, so we have the format sine 3 theta minus alpha, which means we're going to use the sine addition formula. So we're going to make 3 sine 3 theta minus 4 cos 3 theta equal to r sine 3 theta cos alpha minus r cos 3 theta sine alpha. We equate the thetas. 3 equals r cos alpha and r sine alpha equals 4. We get tan alpha by dividing them, 4 over 3. So that means alpha is 53.1 degrees. Let's go 2 decimal place, 1, 3. Typically, in this scenario, alpha tends to be 2 decimal place. To work out r, we're going to do the square root of 4 squared plus 3 squared, which gives us 5. So the format is 5 sine 3 theta minus 53.13 degrees. Final answer. That's part A done. Part B, the minimum value. Okay. The minimum value of this is when? It's when 3 sine, or let's take this actually. Your bracket, 3 theta minus 53.13 degrees, the sine. So in the sine graph, what's the lowest value? What's the minimum value? If the maximum is 1, minimum is minus 1. Now, to this, you have a 5 in front. So the new minimum is minus 5. This occurs when your sine function is equal to minus 1. Now you want to solve. So 3 theta minus 53.13, if we do sine to the power of minus 1 of minus 1, 90 degrees. And then the equivalent is 270 degrees. Okay? If you remember, alpha or theta here, is between 0 and 180. So we can't go with minus 90. Because even if we rearrange for theta, we still get a number that's negative. So 270 plus 53.13 all over 3 gives 107.7 degrees. So here the minimum value that it can take is -5. And the value of theta, which is at which that occurs, is 107.7. Okay, the last one. Solve for 0 to 180 the equation blah blah blah. Okay, so what we're doing is we're gonna solve. Let me just copy it over. We're gonna solve this. Okay, first step is to take the 5 over 1 over 5, 3 theta minus 53.13 equals the inverse of 1 over 5, which gives 11.54, I believe. 11.54 degrees. The interval was originally between 0 and 180. We have 3 theta minus 53.13, so our new interval is this 506.87. Okay, now we do our cast diagram. 11.54, its sign, so it's going to reflect this way, 11.54. So the next value is 180 minus 11.54. So 168.46 degrees. The one after that would be 371.54 degrees. And now if we go any further, we've gone past our interval. So for theta, you would do 11.54 plus 53.13 divided by 3. 21.6. And then 73.9. And then 141.6 degrees. There you go. Done. That is how you work with that particular format.